I think I am live now. Can everyone confirm if audio and everything is fine before we get started for today? Okay, looks like system testing has started. So I think I ended up solving all the problems. So at least I will discuss what my solution ideas were. One spoiler ahead, like my solution for one of the problem is wrong and I have a counter test case for it. So in case I was mostly betting on people that no one will hack it. So here we are. So in case like system test case are a bit stronger, one of the submission can go away. And like I do have a second submission for it, which I would have submitted if someone would have hacked my solution. But let's see if it passes system test or not. And I will mostly reveal it. I will mostly reveal it when like I think the system testing will be over or once we end up discussing this problem. Oh no, why would you say it on a stream though? Like to be honest, it doesn't really matters. Like the context generated for me. So here we are. Let's get started with the problems here. So I can share my intentions for like I do not have strict proofs for some of the problems, but I think we should be good. Yeah, like probably I will see if I end up being second, then I will probably do something. But in case my solution fails, then yeah. So like no hacking phase is there, but system test cases are definitely there. Looks like system test cases started then this maybe next system. Not sure what's happening. From scoreboard, it looks like system testing has started. A and B have been regions. This is internal. Okay, like for writing pad, probably you can ping me on my Discord server. I can share the exact writing pad I am using. Like, I think it's one of the XP pen tablet. I can share the exact one which I am using. And for whiteboard, it's Xcali Draw. So let's start with the first problem. It says Narek has to spend 2 hours with some, like let's ignore the story here. Narek found that kids only know the vowels of English alphabet, the letters A, E, I, O, U. So Narek needs to make a string that consists of vowels only. After making the string, he will ask the kids to count the number of subsequences that are palindromes. Narek wants to keep it simple, so he is looking for a string such that amount of palindromic subsequences is minimum. Help Narek find a string of length n consists of lowercase English vowels only A, E, I, O, U, which minimizes the amount of palindromic subsequences in it. So there are many definitions here. Like palindrome means the string which reads same if you read it from front or the end. Like some palindromic string examples are like these are some of the palindromic string. And then the next word he used here was subsequence. Subsequence means you take the original string, delete some of the characters, and don't change the order and keep the same string. So for example, some of the subsequences here can be like, for example, if you delete these characters, the remaining part is E, E, E. Or if you delete these characters, then the remaining character would be D, E, D. So these are some of the subsequences here. Any question on the, and the problem statement says you have been given a length and you have to create a string of lowercase letters which contains basically A, E, I, O, U and such that the number of palindromic subsequences in it are minimum possible. So and one more thing over here was like one thing which I see the problem statement has not clarified is like what happens if you delete the different characters and it ends up with the same string. Like for example D, E, E, D. One way to delete some character is this, which will give us D, E, D. Another way can be to just delete this character. You will again get a D, E, D. So should we count this DED 2 times or 1 time? Like I'm not really sure, and in the problem statement I did not thought about it much, but let's see. So like the problem statement doesn't really clarify it. For example, in DED, should we count DED once or twice? So probably let's assume that both of them should be same. So like once, like it can or it cannot be same. Like the problem statement has not clarified here. Like do you consider subsequence after you have found the string, or do you consider it based on indexes? By the way, looks like it in fact counts 2 times because this sample shows it 2 times. Yeah, so this works. And then like probably without any proof, what I ended up doing was like, let's say A appears CA times, E appears CE times, I appears CI times, OU. O appears CO times, U appears CU times. Like let's just say we have some string where this is the count of characters we have. Then like what is the minimum possible number of subsequence we can have? Like there would be 2 to the power CA minus 1 different non-empty string which contains only A characters. Like you ignore the empty one. And like let's say we have some string where like this is the count of characters which appears A, E, I, O, U times. A appears CA times, E appears CE times, I appears CI times, O appears CO times, U appears CU times. Then like what is the minimum number of subsequences this string will have? That's the first question I have. You see like there are 2 to the power CA minus 1 non-empty subsets of pick indexes where only CA would be present. And any such subsequence would be a permutation, right? Sorry, it would be a palindrome, right? Like for example, this is how the string is. Then if you pick any set of A here, you will get a palindrome. So total, assuming that all the values are greater than equal to 0 or whatever we call it, like these are the minimum number of palindrome which will contain only string A where A would appear. Like this is the minimum possible number of permutations you can have. Like, do you agree with this one? The count of sum of these values. Because A appears CA times, like that means like these many strings you can get where only A would be present. and doesn't really matter at which place what is the order of A, U in between, but if you look at only A, these are the characters you can get. Okay, so like probably I first started with explaining what is permutation, what is subsequence, and any questions on that part first. And the problem statement asks us to minimize the number of permutations, subsequences, and you have to print such a string. Okay, then my idea was like, let's pick some string of length n where A appears CA times, E appears CE times. Like whatever length n string you have, which is something like there would be count of how many times A appears, how many times E appears, how many times I appears, how many times O appears, and how many times U appears. Then my idea was like, if you look at the whatever sequence, like I am starting with some random sequence right now, like I am not yet trying to minimize it. I am saying if I have a string where I know the count of how many A appear, how many B appear, how many C, how many A, E, I, O, U appear, then there is a minimum number of palindromic subsequence this string will have. Like, are there any problems with the mic? Like, I can probably check it once. Hello, 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 hello. Okay, like all good. Okay, thank you. Yeah, like I know nothing about permutation and subsequence. Yeah, like that's the problem with AI. Like I can probably try reducing. Okay. Yeah, like that's the problem. Like here ended up being relatively hard because probably like easier one AI was able. So I don't really know. But yeah, like definitely like permutation and subsequence generally don't appear in the first problem. Then my idea was if I look at only A characters, then these are the subsequences that I can get. And similarly, if I only look at E characters, these are the subsequences with character E I can get. If I look at only character I, these are the subsequences I can get of character I, non-empty subsequence. Like if I look at only this one, like these are the subsequences I can get using only character O, and these are the characters I can get only U. I am yet to decide what would be the value of CA, E, CI, COU, etc. Or probably let's just say A or whatever you call it. Like this is the minimum number of subsequence, palindromic subsequence you will get if you fix the count of each character. And you can get probably character which contains both sequences, like for example you have AE, AE. Like for example, if you look at only character A, you can get these subsequences. Index, let's say 1, 2, 3, 4. Only index 1 using A you can get. Only index 3 using A you can get. Using index 1 and 3 you can get. If you look at E, you can either use only index 2, only index 4, or only index 2, 4. So like 6 is the minimum possible. And here, like if you probably see, choosing index 1, 2 and 3 will give you AEA, that is also a palindrome. Or choosing index 2, 3, 4 will also give you a palindrome EAE. So total 8 are there. Sir, why AEIOU? Like I will probably say it like, let's just say AEIOUA. Like how many sequences this one gets? Length 1 sequences, there are 6 sequences. Length 2, there are only 2 sequences, AA. And then you can get length 3 sequences as well, AEA, AIA, AOA, AUA. So total sequences you will get is 6, 7 plus 4, to 10. While if you keep it like this, A, E, I, O, U, then you will not get these sequences. Like length 1 and length 2 count is still same, but these characters has gone away. So here this sequence will only contain 7 such sequences, while this one was 6. Like while this one had 11 sequence, and like that is why this answer is wrong. So my main idea was like, this is definitely the minimum you will have. In case you have subsequences which contain more than one different character, you can get more as well. But my idea was like probably create a sequence like this: A, C, A times, then some E, which will be C, E times, and like some I would be there, Ci times, some O would be there, Co times, and some U would be there, which is Cu times. And now you can see like this string does not contain any palindromic subsequence which contains two different characters. Either the sequence will contain only A, or only E, only I, only O, or only U. Because let's say if you end up choosing some two character, A from here, E from here, you will not get A here again. So like once if we know the count of how many A, E, I, O, U we want, then this is how we should print the characters here. Yeah, and then the next idea I had was like probably let's see how does the characters happen. Like let's say if we had A 5 times, then here the number of palindromic subsequences 2 to the power of 31. But if you change this A to E, here the sequences you will get is 2 to the power 4 minus 1 plus 1 due to E, and you see like this is 31, this is 16, and like this count almost half. And like we can do some more bits here, like let's remove one of the A and add one I as well. Here due to A you will get 2 to the power 3 minus 1 plus 1 E plus 1 E, and the sequences you have got is 9. The count has almost half as well. So this gives us an idea like we should keep numbers as close as possible. As close as possible. And like that is essentially the idea, like you just first create a length of string n where you have a string like this, like get n characters from a string like this, and then sort all the characters. Like I agree, like A is definitely harder than normal problems. Like I don't think I generally take this much time to just explain A. And that ended up being the solution for problem A. Any questions on this one? Like I have skipped the strict proof why these should be as close as possible, but if you want to try out, you should probably use this idea. This is the idea you can use to prove like what happens if the characters are not as close as possible and why this is better. So this was problem A. Yeah, like I agree. Like A was really harder than general contest we have, and the reason is probably ChatGPT. So the idea is while size s is less than n, s plus equal to 2, or probably a e i o u, and then the idea is like if you have more characters, just with sizes. And like this would be the solution for problem. Looks like system testing is still not over, so I will probably submit this solution, right? I will submit once system testing is over. And by the way, fun fact was like my D was wrong, and looks like my solution has passed the system test. So I have one more solution for it, but I don't have a proof of why the new solution will also work. And I was just waiting, like if someone hacks it, I will submit my second solution. And once the system testing ends, like I will probably add the test case I had for my D. Yeah, so that's where we are. Any questions on problem A before I move to problem B1? Okay, yeah. Okay, everything has passed here. And yeah, now probably I will add jingly doesn't count. So yeah, probably let's go. Like generally the stream is 2 hours, but ends up being 2 hours. But then like let's see, like the strict no, like exchange argument is required to prove that like lower bound is achievable is fine, but exchange argument is required to show that the count of all the characters should be as close as possible. So for example, if the string length required is 25, then all the characters must be 5, y a cannot be 4 and e cannot be 6. For that proof you need exchange argument. So like let's first see the easy problem. This is easy problem. Like here says Narek and T like Tosovak were busy preparing this round, so they have not managed to do their homework and decided to steal David's homework. The strict teacher noticed that David has no homework and now wants to punish him. She hires other teacher to help catch David, and now M teachers together are chasing him. Luckily, the classroom is big, so David has many places to hide. The classroom can be represented as one-dimensional line with the cells from 1 to n inclusive. At the start, there are, for this problem, n is equal to 2. It says at the start there are 2 teachers and David are in distinct cells. All 2 teachers, both the teachers and David are in different cells. Then they make moves. During each move, David moves to an adjacent cell or stays at the same cell. Then each of the M teachers simultaneously move to an adjacent cell or stays at the current cell. This continues until David is caught. David is caught if any of the teacher, possibly more than one, is located in the same cell as David. Everyone sees others moving, so they act optimally. Your task is to find how many moves it will take for the teachers to catch David if they act optimally. No, it's not necessary that David will stay at its same position, but like I will show how the game is playing here. Acting optimally means the student makes his move so that the time when he is caught is as late as possible, while teachers coordinate with each other to make their moves such that the time taken to catch David is as soon as possible. Also, Narek and Toshial think this problem is easy. They decided to give you Q queries on David's position. In this case, Q is 1. Note that this is easy version and you are given only one query. So in this problem, like the arrangement looks more like this. like no one is moving first, like both of them are moving together at some place. So like for example, like let's say one of the teacher is at 0.45, David is at 0.12, and another teacher is at 0.18. So like what will the teachers do here? Like let's say the number line is up to 100 here and number line is up to 1 here. So the best way for teacher would be like there is no point in moving for this teacher to move on this side because this gaps between David and teacher increases. Similarly, there is no point for this teacher to move on that side because now if David moves this side, the distance between these two either remains same or increases. And like that was the first observation. Like once an arrangement is like this, both the teachers should move towards David. Doesn't really matter what other teachers are doing. So for example, this teacher should move this side, this teacher should move this side. And if David does nothing, like this distance is 7, like let's say David does not move anywhere. Let's call it 9 at index 9. Then this teacher will catch David in time 4. And like this teacher will catch David in time 9. But what David can do is like he can probably move to the midpoint of these together, which would be 5 plus 8, 13 to 11. Like after the first move, like teacher moves to, this teacher moves to position 6, David moves to position 10, this teacher moves to position 17. So at time t equal to 1, one of the teacher is at time 6, David is at time 10, and this teacher will be at time 17. In the next move as well, now this teacher will take 4 more seconds and this teacher will take 7 more seconds. What David can do is David can move one more on this side. So this teacher is moving this side, this teacher is moving this side. So at time t equal to 2, like one of the teacher would be at position 7, David would be at position 11, and this teacher would be at position 16. Now this gap is 4 and this gap is 5. So like now David can wait here. After 4 seconds this teacher will catch and total time would be 6 seconds. Any questions on like what is happening if David is between two teachers? Any questions like why it is optimal for David to move to the midpoint of both the teachers if he is between both the teachers? So like that is the main idea. Now like let's say the configuration is more like this: David, teacher, David. Let's say David is at 0.3, teacher is at 0.7, and this teacher is 0.7. So it's optimal for David to go to 1 and then stop there. So that this teacher will take 10 seconds to catch her and this teacher will take 17 seconds to catch her. Similarly, like if the configuration is more like this, let's say this teacher is at time 3, 10, 14, and like the number line is up to 20. So it's optimal for David to go to 20 and then stop there, and this teacher will take 10 seconds to catch her and this one will probably take 17. So this is the idea. Like basically there are 3 cases on this problem. If David is on left side of one of the teachers, then he should go to point 1. If David is on right side of both the teachers, he should go to the last point. If David is between both the teachers, then he should go to the midpoint of both the teachers and see whoever catches himself. So this was the idea for problem B. Any questions on this one? Like I can probably share the code for this one. So the idea is like I have read two integers, I have sorted them. If David is on left side of the first teacher, then like this would be the time for this teacher to reach pointer. If David is on right side of the second teacher, then this would be the time second teacher will need to go to pointer. Otherwise, like let's say midpoint. So the answer is like first teacher will need this time and second teacher will take this much time. And like whoever reaches first will be able to catch David. Like it doesn't matter if the distance is even, like any of the midpoint will take the same time. So this was problem B1. Any questions on B1 before I jump on to B2? Okay, the idea is same for B2 as well. What we really need is what are the nearby two teachers of the David. There are different queries. Like let's say now there are multiple teachers. This is the number and it starts from 1. It goes up to let's say 20. One of the teacher is at 3, one of the teacher is at 7, one of the teacher is at 11, one of the teacher is at 16. What we need is like if David is somewhere here, then he should go to 1. Like if David, like these are the teachers, by the way, teachers. If David is somewhere here, he should go to 20. Otherwise, you should look at what is the teacher just before it and just after it. For example, if we are here, if David is somewhere here, he should go to midpoint of 7 and 17, which would be 0.9. If David is somewhere here, he should go to midpoint of 3 and 7, which would be 5. If David is somewhere here, he should go to midpoint of 11 and 16, which would be around 13. And like essentially that is the solution. The like although there are many teachers, what really like one teacher on left and one teacher on right would be the faster to reach it, because like you see like David cannot cross this teacher, so that teacher 3 cannot cross it. Like if David is here, let's say if David tries to cross this teacher, then he will be caught then and there itself. So like 3 cannot caught it faster. And like this ends up being the next solution. The idea is you can binary search to find left and right. Right teacher indexes. Or like alternatively, like you can use inbuilt library function lower bound or upper bound as well. And like that was the idea. Like you can like this problem, you can just code binary search or you can use the library function. Like I'm not sure like how will you use prefixes over here. Like all the coordinates are up to 1 to n, like you can probably pre-compute the answer from 1 to n and call it a day. So if current value is less than A0, you print this. If current value is greater than A0, you print this. Left teacher would be at this coordinate and right teacher would be at this coordinate. So like now you can again find a midpoint for left and right. T1 would be this, and you can print the minimum value here, and this ends up being the solution of B2. Any questions on B2 before I move on to problem C? Like, is system testing over? Like, I do want to make some submissions here. Yeah, like the values are up to n, so you can definitely pre-compute it. Or like you can probably keep the left and right teacher for each of the value by running a for loop as well. Like you don't really need a binary search because values are up to n as only. So like you can also avoid the binary search because like everything is between 1 to n. So for each index you can compute what is the nearby left teacher, and for each you can compute what is the nearby right teacher. And like that is probably like prefix max for each index and suffix min for each index would do. No, so we don't need prefix sum, but prefix min or prefix max or suffix min can also do the job here. So any questions on problem B2 before I move on to problem C? Okay, let's go to problem C now. Lazy Narek. Narek is too lazy to create third problem for this story here. His friend Arthur suggested to use ChatGPT. ChatGPT creates n problem. Each consists of m characters. So Narek has n strings. To make the problem harder, he combines the problem by selecting some of the n strings, possibly not, concatenate them without altering order. His chance of solving the problem is defined as score n minus score C. Like the problem is definitely DP. So first thing first, this says like Narek has n strings. Each string is of length m, and like now like he will select some of the string and create one string which is of the longest possible. Like he will choose one of the string and he will combine one after the other, and he will not change the order of the strings here. Like this is critical here. Narek calculates score n by examining the selected string. He moves from left to right. He initially searches for the letter n, then character A, then character R, then character K. And once he gets all the characters, he increases his score by 5. And then he starts by searching n again. He doesn't go back to the starting, just the first character. And he continues from where he left off. After Narek finishes, ChatGPT scans the complete array again and increases score by 1 for each character Narek which the ChatGPT finds. Narek fails to utilize. Note that if Narek fails to complete the last occurrence of finding all 5 characters, then all the characters he used are counted in ChatGPT's score. Narek doesn't get any points if he doesn't finish finding all the characters. Narek's score is to find the maximum value of his score minus ChatGPT's score by selecting most optimal subset of the string. Basically, like any example which I should probably dry run it over here. Okay, looks like system testing is over. So I will submit the solution for AB so that you guys can refer it later on. Okay. Okay, I will have to probably share the generator here. Okay, like the main idea is let's say let's first forget which strings to choose and see what is happening after we have fixed the string we want. Like let's say we have this string. Like I am ignoring all the characters which are not this because they does not impact the score. Like let's say this is the string we have. The Narek, and let's also probably add some here. Like first Narek will choose this one, then this A, then this R. Then he will choose this C, and this K he will get plus 5 points. Then he will choose this N, this A, this R, this C, this K, he will get plus 5 again. Then although he will choose this because he did not completed anything here, he will not get over there. Like I will probably say, well, like when I reach that problem, like what the heck? Okay, I don't know why it's unexpected. Okay, unexpected might be because like the hacker solution may also be wrong here. And then like ChatGPT will start choosing these characters. -6, which is around, let's say, 4 points. Like in this case, like Narek is getting 4 points, but there is some another way to look at it. Like give ChatGPT all the characters. And then do plus n whenever Narek takes character from ChatGPT. Do plus 10, like whenever Narek takes 5 characters, instead of doing plus 5, do plus 10 characters. Because you see, like your score is score n by minus score ChatGPT. You initially gave all the characters to ChatGPT. Now when you are moving characters from ChatGPT to here, Narek's score is increasing by plus 5 and ChatGPT's score is increasing by minus 5. And this minus minus cancels out and we are getting plus 10 here. Does this make any sense? Like let's say like total 100 characters are there, which is of like total we have 100 Narek characters and we formed 5 strings. If we form this 5 strings, then like Narek score would be 5 into 5 and like ChatGPT will have remaining 100 minus 25 equal to 75 characters, which is minus 50. Or another way I can do is I can say Narek will get 10 points for each completed string, and ChatGPT can take all the 100 characters, which is also minus 50. Like this was the main crux of this problem. Any questions on why I am doing plus 10 instead of plus 5, and I am also giving all the characters to ChatGPT? Like once you realize like you can write a scoring function like this, then like the problem will be a bit easier. So like this was the crux of this problem. You give all the characters to ChatGPT, and when Narek is taking characters from ChatGPT, do plus 2 plus 10 instead of plus 5, and this is our solution. Like any questions on this first? Before I jump on, like how do you decide which strings to take and which strings to remove? Okay, now once we have this, my idea is we can define a DP like this, DPN. Like basically 5 different values like this. Like don't go how like the string can be an index, but let's say assume like we have 5 different DP states like this, or probably we don't need it, or we can say like we have a DP like this and an empty string here, 5 different vectors like this, and this denotes, like for example, DPI NA denotes we have chosen some strings from S1 up to Si, some set of this, we have chosen some subset of this string, and like the last 2 characters Narek got is NA. Like once we have first chosen which strings we want among the first S1 to I, and the last 2 characters Narek has right now is NA, and what is the maximum score he can get? What is the maximum score? And like this is essentially the solution for this problem. The idea would be like if you don't do anything, then DP I plus 1 NA will be, if you don't take I plus 1 string, this will happen. And if you take ith string, if we take, let's call it I minus 1 and string I. If we don't take ith string, then DP NA would be DP I minus 1 as well. Or if we take the ith string, then we can see like if Narek starts with NA and processes ith string, which would be the final ending character he will get. Like let's say he starts from NA like this. This is the ith string. R, E, K, N is there. Then he will end up with string N now. Just N, and overall score he would do is like -4 for ChatGPT, and he will complete one of the string here, so he will do plus 10 here. Like that is the idea. Like assume that you start SI and there is character NA added before it, and let's say there are all the other characters are different. R, E, K are the only characters here. Then we will do -4 for ChatGPT score, And like when Narek reaches here, his string will become empty, and we will do plus 10 there, and then the next character taken would be n. So if we take na, we add the ith string, we will end up with just string n, and overall whatever the score was would be our new score. So we can say like dpi n is equal to max of dpin plus 6 dp I minus 1 na. Max of this comma 6 plus this. Any questions on this one? So like this is the idea. Like now instead of maintaining the string at index, you can see like how many characters you have taken over here. So for example, dp I na becomes like dp I comma 2. You have like taken 2 characters. dp empty string becomes like dp I0, like 2d dp we have. And this essentially ends up being the solution for this problem. Any questions on this idea? I will probably jump onto the code now. So initially, like we have this string t, which is Narek, and like probably we can have also a set of all the characters. We can also have a set of all the characters. So here the idea is like in starting you have no characters, so dp00 is 1. This is the ith string. If we do not take this string becomes dpi I minus 1. For example, we have already taken j characters here. So the current value we would have is dp I minus 1j. And like the number of characters we have taken so far is k. Now we iterate on this string. If the current x is one of Narek, I do score minus minus. If the current character in t is x, I also increase the k, like how many characters I have taken. And whenever I reach the end of like, or whenever I have taken all the 5 characters, I do plus 10 here. Like probably instead of m, I should replace it with 5 every time. And at last, whatever the character we have got, we can say dp ik is dp ik and score we have got. And our answer would be maximum value in dpn. Yeah, like I can dry run on one of the examples here. So like dry running this big example might not be feasible. Like complete dry run might not be feasible. I can say what I can do over here. Like for example, like let me write down the example for the last. Like I won't take the full example, but some part of it. Like let's say we have this question. This is the first string we have. So now like in starting when we have not taken any characters, the score with empty string would be 0, empty string is 0. And for any other DP values here, like let me probably draw this DP here. Empty string, string n, string na. Let's say this is NAREK, RE, and this is NAREK. Like we don't need the full string by the way. So and final we don't need because we will keep it empty. 0, 1, 2, 3. So when we have taken none of the string, you will have Narek will have an empty string. This is minus infinity, minus infinity, minus infinity, minus infinity. Now, if we do not take the first string, our score will be like this. Like the values is same as above. And if we take the first string, then these cases are impossible. And in these cases, like Narek will start take this n, ChatGPT will get -1. This R, ChatGPT will do -1 again. And now like in this case, Narek will get character n and ChatGPT will do -1. Now Narek goes to this string, he will get nr. And the score right now is -2. This R Narek cannot take it because he want A, but ChatGPT will still do score -3. Then this is the character A. Then Narek will take this character A, but ChatGPT will also do -4 here. Then this is R again. ChatGPT will do -5. Then this E, and here like the ChatGPT will again do -6, and Narek will also get E character E. And here then when Narek takes this character, ChatGPT will do -7, but because Narek got the full string, he can also get +10 here, and this string is vanished now. So if you process this string, overall delta you can get is 3, and the string is empty here. So like instead of if you take the character 3, then you can end up with empty string and with the score of +3. Now for the second string, if we do not take this string, and you cannot start with NA something because the score is 0 here. 3, -infinity, 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 -infinity again. Yeah, Narek starts with empty string and score of 3. He takes this string 3 and ChatGPT does -1. Again R, ChatGPT does -1 again. Again N, Narek cannot take it, but ChatGPT will do -1 again. E, and A, R, Narek can take string E and ChatGPT will do -1 as well. K, ChatGPT will do again -1 and Narek cannot take it. A, then like Narek can take string A, but ChatGPT will do -1 again and -1 again. 1, 2, 3, 4. So like if Narek starts with empty string on this string, he will get this string and score of -4 here. And this -4 is definitely better than -infinity. This is how the game is going on here. Now when we are here, if we start with empty string, you can probably see something happens. Like for each string, we will transpose 5 times, right? Based on how many characters Narek also has got. Now Narek has two choices here. If he does not take this string, his score will be 3, -infinity, -infinity, -4 and -infinity. And let's say if he starts with here, his string is this, he has -4. ChatGPT will do -1 again. Okay, ChatGPT will do -1, but he will get +10 as well. And he will have empty string now. Then -1, -1, N is not there, -1, -1, Z does nothing. So 10, -5, -6 and then +10, 4. -1 again, -1 again, -1, overall score 0, and he can end up with the empty string with the score of 0. And like this is how the problem is running. So any questions on problem C? And like I think I have shared the code before as well, so I will just go ahead and submit it. Any questions on problem C before you move on to problem D? Like looks like editorial is also out. I might be interested in what the other solution is. Okay, looks like it's fine. Like I will probably move to problem D then. So let's say problem D. It says alter the GCD. You are given two arrays A1 to AN and B1 to BN. You must perform the following operation exactly once. Choose some indexes L to R such that like L is greater than 1, less than R, and R is less than N. Swap AB for every value in between from L to R. And it says find the maximum possible value of this GCD. GCD of first sequence plus GCD of second sequence. After performing the operation exactly once, also find the number of distinct pair from L to R which can achieve this maximum value. So any questions on the problem statement first before we jump on to the solution? Okay, let's solve this problem simpler. Let's just find the maximum possible value of GCD of A1 to N. We don't, for now, let's not count the number of pairs, neither let's take sum. Let's just take this one. Then what we can probably do is, like, let's try to find the GCD of only A and only the maximum value, not the number of A's here. So A1, A2 up to, let's say, some AL would be there, AL minus 1 would be there, some AL would be there, up to some AR would be there, AR plus 1 would be there, and up to some AN would be there. And let's say we swap from AL to R. So here we will have BL up to BR. So what can I do here? I can maintain, like, if you notice, like the final value is GCD of all the values, and if you see the value up till this would be or probably first thing you see is like the final GCD is divisible, is the factor of this. Looks obvious because like you will take this as a GCD and everything will go over here. And probably like one thing which I can probably want to do over here is, let's say this is phase 0 of R swapping. This is phase 1 where we will take B, and this is phase 2 where we will take again A. Then what I can do is probably I can maintain DPI 0 all possible GCD of A, or probably let's call it G not DP. GI1 means we have reached the index I, we are in phase 1 and all the possible GCD. And GI2 means now we are in phase 2 and what are the all possible GCDs here? Like this looks fine, right? We can probably maintain these as 3 different sets here. Like let's forget the time complexity right now. You see like why this will work here or what is going on here. Like from phase 0 you can directly go to 1, and if that is the last index you can probably go to 2 and you can do everything here. Like what I am doing is, let's say like phase 1 is where we would be using 2 and all the values before it is my phase 1 and all the values after it is my phase 2. And GI comma 0 denotes, so far I am only in phase 0 and what are the all possible GCDs I have. This GI2 1 denotes, currently I am in phase 1 and what are all the possible GCDs I can get so far. And GI comma 2 denotes, now my current index I is in phase 2 and what are all the possible GCDs I can get. Then you see at last you can look at GN comma 2 and take maximum value from it. Right now it's not obvious why it will pass or it will get TLE, but this should work, right? Any questions on this brute force idea first? I am yet to analyze time complexity. I am yet to say whether this idea will get a TLE or not. But at least this brute force should give me an correct answer over here, is my first claim. And my next claim is like overall time complexity for this idea is order of n log n. And this comes from the fact that if you repeatedly do GCD, let's say A comma B, Then you do GCD of A, B and C. Then you do GCD of A, B, C, D. And if you keep doing it with numbers like this, let's say GCD of A, B up to, let's say 26 numbers. Then this set only contains log A different values. Log A different values. Like, this is a bold claim. I can try to prove it, but like the idea is like first your GCD would be A. Like the main idea comes from, like, if you look at any number, let's say let's say to C60, then factors of 60 are 1, 2, 3, 4, 5, 6, 10, 12, 15, 30 and 60. And whenever you take GCD, you get one of the multiples only. So if you do GCD of 60 comma some x, say, then either you will have 60 again, or you will get one of these values. And you see all of these values are less than equal to 60 divided by 2. So in this set, either the values will remain same, or whenever it decreases, it will decrease by half at least. So now any questions on why, like if we take a number, we repeatedly do GCD with some other number, either the value will remain same or value will decrease by half at least. And at one point you will get 1 back, and all count of different values you will get would be some log factor only, log with base 2 to be more precise. And this is why I am saying, like, this set, if you are in phase 1, you will have only one or two different one value here. Here you will get around log A1 plus log B1 different values. Like let's say if you switch the starting at B1 index only, and here the values will again keep decreasing. So here also you will have around log A1 plus log B1 different values. So overall time complexity would be like both of these are approximately equal, and that is how I will found if I have to take GCD of only the first array. This is how I will find the maximum value of only A, not the sum, and if I have to not count the number of A's. So any questions on this before I move to the next subproblem? Like I am increasing the constraints one by one. Okay, now let's change it a bit more. Like let's say we still want to count the maximum value of A, but we also want to count how many ways are there. Then the idea would still be same. Instead of this set, maintain a map. Use map here. Basically DP IG denotes number of ways, IG0, and let's say phase 1. Number of ways to get GCDG, and we are in phase 2. We are in phase 1. Similarly, phase 2, phase 3, and so on. And still the solution would be order of n log AI or 10 to the power 9 whatever. Like basically a log factor here. I'm not interested in what value it is. And this is how I can count what can be the maximum value of GCD of A, and what can be the number of ways to get that maximum value. Any questions before I move on to sum of both the GCD of both the arrays? So now, like, it looks intuitive. Like, what we can do is we can maintain DP of ith index. Which phase are we in? 0, 1, 2. G of A, basically GCD of A, and G of B, GCD of B, right? Like, now what I have done is, like, I have introduced one more dimension here. My idea would be, like, I will keep computing it for every value. At last, I would take what is the maximum value of GA plus GB, and for all the maximum values, and this contains number of ways. Let's say this is G10. Number of ways such that GCD of, we are in phase 1. GCD of A is GA, GCD of B is GB, and that is what I am doing. And like, for now, like, I will give an incorrect proof and then I will give some counter example. So, like, based on our earlier proof, you see, like, this one will probably have around log different values, and this one will have around log different values again. So overall, it looks like this solution should be log square here, and we can get an AC here. Looks like, right? Like, because if we look at number of states of DP, there are n states here, 3 states here. Intuitively, it looks like there would be log different values for GCD of A, log different values for GCD of B. So overall, our time complexity should be n log square here, and looks convincing enough to make a submission, I think. So in context, this is what I did. I got an AC. I have a counter example why the time complexity is not n log square, and that was the hack I made. And looks like one of the author or tester submission also got a TLE on my hack. So like, this is the main idea here. First, I will show this, and then I will probably dive like why the time complexity is not n log square here, what can be the worst test case complexity, and I can give one of the counter test case here. This was my in context submission. The idea is like, I am maintaining a tuple, basically maintaining all the values in a map here. So like, if we don't do anything, then after the first index, GCD of A would be 0. We would be still in phase 0. GCD of B would be B0 and number of ways plus 1. If we do a swap operation and if we just start swapping, then we would be in phase 1 and plus plus. And phase 2 denotes we have completed the phase 1. So like, if our left and right index are just 1, index 0, then we would directly jump to the phase 2 and we do plus 1 for that as well. Now I iterate on all the other indexes from 1 to n. This is my AI, this is my BI. I create like what would be the new DP value over here. Like, you can probably put it in a vector here. So we are up to index 0. Like, just some non-trivial way to using a vector to avoid 3-dimensional DP. So now let's iterate on all the values of the previous array. Which phase we are in? This would be the first index in this vector. GCD of A, GCD of B so far, and count of all the number of ways so far. Now, if we are in phase 2, we don't have a choice. We will have to append AI to GA and BI to GB, and whatever the number of ways we get would be still same. If we are in phase 1, we have two choices. First thing first, we will have to swap the numbers. So I take GCD of A with B1 and GCD of B with A1 because now I have swapped the integers. Either I can stop, like let's say like I will want to take more elements in phase 1, or I say like this is the my index R. In that case, from next index onwards, I would be on phase 2. So like this element will still be swapped and this would be the number of phases. Otherwise, I am in phase 0 right now. I have a choice. I don't do anything, and like A is appended to GA, B is appended to GB, and number of ways count continues. Either I say this is my left index and I am yet to decide my right index. Then a swap happens. So I take GA GCD with BI and GB GCD with AI, swap here and number of ways count. Or I say my left and right index starts and ends here. In that case also, like index I would be swapped, but from next time onwards I don't have to take GCDB here. Now I can iterate on DP n-1. I should be in phase 2 because you see like it says we have to do operation exactly once. Phase 2 denotes I have finished taking all the elements for the swapping. This would be my GA, this would be my GB, and this would be the count of ways I have. So I can say count of this would be the sum and this would be the maximum count. And like the maximum value in this would be res dot begin last. Let's say this is sum count. So dot index would be the maximum value of sum and this would be the number of ways. We don't need a mod because you can see like number of such arrays is around n square only and n is up to 2e5. I ended up submitting this into the contest and I did got an AC on it. Looks like time complexity is n log square, but it's not. Okay, why did system testing started here? Okay, my main idea is for the counter tester. Okay, this should be I. This should be GB, this should be G. Okay, in context this did pass, but let me show you something here. The problem becomes tricky when you have two arrays. Let's say we have this as an array, 60, 60, 60. Let's say this is A, this is B. 1, 2, 3, 4, 5. Let's put all the factors of GCD. 6, 10, 12, 15, 30 and 60. Let's also put all the numbers 1, 2, like let's just put everything 60 in this array. So now you see, like, let's say we are in phase 2 here. If we make a swap here, we would get GCDA equal to 1 and GCDB equal to 2. If we make a swap just here, GCDA is still 1, but GCDB becomes 4. If we do a swap here, only this index, then we can get up with the state like GCDA is still 1, but GCDB becomes 3 and so on. So you essentially see, like at this state, the number of different phase 2 we can get would be the count of divisors of 60 so far. Phase 2 up to index 6, phase 2, GCD A is 1 and this wildcard can be number of factors here. And like in the worst test case, like you can try to find which number has the largest number of divisors. Like I had some heuristics and I found like this number has 1024 divisors. So essentially, if a test case looks like this, where array A contains only one of the numbers, one of the factors, and everything else is this number, then like my overall time complexity would be n into 1024, which is number of factors count, and then some log factor here. And this is in fact a TLE. And I'm not sure like what are the better ways to solve it. Like the test case I have constructed is took this number, found all the factors of it, and then just created repeated copies of, let's say 1024 is there. Let's say just construct repeated copies where every number appears 80 times and all the numbers are in increasing factor. My solution takes 12 seconds here, not something I can do. One of my idea again was like probably just to combine all the continuous factors which have same value. But now I see like that might also get a TLE or something. So at this point, I'm not really sure like what should be the better solution for this problem. At least the solution I have takes 12 seconds, although it says 6 seconds, 0.6 seconds here, and it's definitely a TLE. So this was my idea for D. Like I have said like some observations, etc. But to be honest, I don't have a full solution for this problem. Although I am ranked to there, but my solution doesn't really work. And I tried to hack my own solution over here. I got an unexpected verdict, which literally means like one of the authors or tester solution is also getting TLE on the test case I have. Like I can give some small snippet as well, like how does this test case looks like. I can say that, and then I will probably move to E now. Any questions on D? Like let's just put 60 here. So the test case looks more like first array contains 10 times 60, 10 times 30, 10 times 20, so on. Total 20 factors are there. So 10 value and second array contains only 60. So I have a similar test case where instead of 60, I have one number which has around 1024 factors. And let's say this repeats around maximum possible time I can get. And this is the counter test case I have. And I think a few more submissions can get a TLE on this one. So any questions on problem D before we move on to problem E? Like, I don't really understand what GCD has first. Like, I would be more interested in this solution. Like, did it add some DP on the sum etc. and did it remove some excess state? At least in my solution, I did not remove. Like, I agree on this one, like the count of prefix and suffix GCDs can be different, but I don't really understand what happens when you swap between the two. Like you can probably brute force on, like there would be around log and log A values for one of the GCD and log BI values for one of the GCD. So around 120 such value, and you can have phase 1, 2 and 3 for 120 such values, but don't really know. So any questions on problem D before we move on to problem E1? Okay, so problem E says, let's first read the easy version. This is easy version of the problem. The difference between two versions are constrained on all the variables. You can make hacks if only you solve both the problems. Like, not really sure why it was good. T and N are playing a game. They have an array A and a matrix B of integers with n rows and n columns numbered from 1. The cell in the ith row and jth column is I, j. They are looking for the elements of A in turn. T starts first. Each time a player looks for the cell in the matrix containing the current element of A. T takes first turn and then for second. Let's say a player has chosen cell R, C. The next player has to choose a cell in the matrix starting from R plus 1, C plus 1 up to n, n. The matrix can be empty if R equal to n, C equal to m. If a player cannot find such a cell or the remaining matrix is empty or the array ends, the previous player who has chosen the last element wins, otherwise he loses. And the problem statement says, like, we have been given A, B and we have to find all the values here. And like, sum of length of A is up to 300, length of n and m is up to 300 as well. So main idea is probably to use a DP here. AP or alternatively, like, let's first see how does the game happens. Like, because everyone can see the future. You see, let's say we have A1, A2, A3, or like probably I would like to take one of the examples. Any suggestion on which example which you would like to see? Like, let's say our A is 1, 2, 3. Our element B is now, like, let's move it from the reverse. If all the elements have been processed, then whoever starts right now would lose the game. So dp like 0, 1, 2, like let's say dp4 I comma j would be false. Like the starting player will lose here. So everyone will be a loser here if all the elements have been taken. Now let's look at the turn just before it when the value is 3. We know that whoever starts right now will lose. So what we can show is like if the player chooses this value, then the next cell one can go would be this only, and this is again like so. If on the last turn the player chooses this element, then he can win because all the states in this submatrix would be losing state. So I can say for the second last cell, like one cannot choose this cell, so this is definitely a losing state. One cannot choose these cells as well, and this will be a winning state because this matrix contains only winning positions here. This will also be a winning state because this matrix only contains losing states here. This is also a winning state. If the last player chooses this element, he would win because all of these are losing states. So for the last cell, like this is how the winner, like whoever picks the last element, if he chooses this element, he will win the game. If he chooses this element, he will win the game. If he chooses this element, he will win the game. So the last player definitely wins. Now let's say what happens if we choose 2. If the let's say second player chooses this element, he will win because like there is no turn for the next player. So this is definitely a winning position because we have to choose 2 here, we cannot choose 3 or we cannot choose 1 either. But let's say if the second last, whoever is second last chooses this element, then this would be the remaining matrix and one cannot win in this matrix. We know like all of them are losing state. So this element is also a winning state here. But what happens if second last player chooses this element? Then this would be the remaining matrix here for the next run, and this is a winning state here. So we said like if the second last player chooses this index, he will lose because after that someone will choose this index and then there would be no turn. So although 2 is there, but this is a losing state. Similarly, if second last player chooses this 2, then he would be, next player would be remaining with this element. So like if second last player chooses this as well, he will win. So this is how the matrix looks like when the second last player wants to choose 2 based on where he chooses 2. Now one has to choose 1 and 1 because our array was 1, 2, 3. So let's see how does last turn looks like. One cannot choose this 2. One cannot choose any of 2 or 3. So these are definitely losing state. And for this 1 and 1, if someone chooses this one, this would be the remaining state. And if everything here is losing, then one can choose here. Like this was for choosing 2, right? And this one has a winning state. So if someone chooses this as the first element, then the next player can choose this and can win the game. So this is also a losing state for 1. And if the third last player chooses this one, the next player would have this as a matrix here. And this matrix has at least one winning position. So this is also a losing state. And because whatever the first player chooses, he will lose. So the answer would be like print T, the second player, which is Trek. And if had this been one of the winning position, we would have printed Narek. Any question on this brute force? And this was the idea for E1. There is one more optimization required for E2. First thing I did was, like I reverted the array A and I have also reverted the matrix B. so that instead of the remaining right side, I look at the left side there. I reverted the array A, so that because I am processing from the end, and I have also reverted the matrix B as well. So like, let me show you how does this looks like. So A has been reversed. Like, let's not subtract -1, not really required. No, like this should definitely work. You may have some bugs there. So I have reverted B and I have also inverted A here. So the last element here was 2, which is first element here. The second last element here is 5. So the first element here has become 5. So instead of choosing the remaining part in suffix, I would choose the prefix part here. So the idea is like, initially everything is a losing state. Like, let's see if the starting matrix contain any winning state. What I need is like, is OR of all the values in index 0 up to I and second index 0 up to j. Like, this is the first thing I'm doing. So there are two ways to do prefix sum here. Like, either I can probably maintain the count of winning position in a sub matrix, or I can just do like first prefix sum on rows and then prefix sum on column. This is another way to do it. And then I start from the ending index, or like, I think and the next thing was like, I am processing all the indexes. Like, I don't really need a suffix. Like, for all the indexes starting from reverse, if current element is not equal to the element we want to pick, then this is a losing state, false here. If my I is greater than 0, j is greater than 0, and there is at least one winning position in 0 up to I minus 1 and 0 up to j minus 1, then I cannot choose the current element, so false here. If there is no winning position, then this is true here. This is what I am doing, and at last I am checking, like, after I have also processed the first element, does there exist any winning position for the first block? If the answer is yes, print T, if otherwise print no. This was the idea for E1. Any questions on E1 before we jump on to E2? There is only one difference for E2. Like, let's say we have this matrix. No, like, not reversing it does not changes anything. Like, let's say the first player has to choose numbers. This is my array 1, 2, 3 again. This is my array B. So like when we are processing from reverse, you see if we choose this element, the next player has these many as the remaining submatrix, where he can probably play to. But if the first player chooses this element, the remaining part would be this only. So does this make any sense to choose this element at any point of time? Because a 1 already exists below it. Because if we choose this right now, other player, this would be the area next player can play up to. But if we choose this, we will get this area, and this area is strictly less than what we have in blue area. So my claim is like anyone who wants to pick, he should never pick this one. He can probably pick this and he will get some better chance of winning. Like any questions on this? Like similarly, because this one exists, if you choose this right now, anyone would have this as the remaining area. But if you choose this, he will get this. So we can just delete the, forget that these values exist. Like we will need this one. We can forget this value exists. And yeah, like my main idea was like, if I am doing reverse, for every row only keep the first time an element appears, remove all the times when that element comes back again. Or let's just say like this is a losing position. And like once you do this, you see A contains L elements. And if you keep deleting rows from every column, you will have at max L elements in each row. Let's also remove the values which are not present in A, because you will never remove that. This row will have L values at max which are present, like because for every value we are keeping only the last element when it appears. So overall you can probably get is a matrix probably of size n cross L, let's say. You will have to be a bit more careful with the rows or columns where it appears, but say like only these many are the helpful values we have. Like if I only like L is the length of it, then these are the only helpful values I should consider at any point of time. I can just ignore all the other values. And let's say when you are deciding where to put AI, for every row, like you only put it on the last element of that row. So like the, and like, so you will have only n possible choices here. N possible choices. So if you implement it carefully, like overall you can get order NL time complexity. Our earlier time complexity was order of NML, which was enough for E1, but only N into L would be required for E2. And like this is essentially the solution for E2. Like you will have to be slightly careful on how you implement it, but that was the idea for this. I can probably share my code for this. We don't need coordinate compression here. We don't need coordinate compression here as well. Like first maintain a map of where all the elements are present. So for Bij, put Cij. And only like let's say keep best. We have this method which will keep only one value in the best, because I am doing in reverse. I will keep the smallest value in every row. First of all, we also need the values in A. So like if only if Bij is present in A, then you keep this value. Like you remove all the values which are not present in A. Then you go over all the cells and only keep the best value in that cell. Like for every row, like let's say M is the best value so far. So you iterate over all the indexes. Now the idea is same, like you use the same DP solution here. Just ensure that you only iterate on the elements which are present in cells here. And you will need some more 2 pointers idea something here, but at the end of the day you would be able to get it. Like let's say this win pos contains winning position, new winning position we want to find. For each element, let's find the smallest winning position, like the minimum index where someone can win. Smallest win column. And you will also need a prefix minimum. Prefix minimum. Now new winning positions. Like the new values we want to find. I look at for all the earlier positions I have found for the current cells. If R equal to 0, this is definitely a winning position. Otherwise, like smallest win column in R is less than C, then this is a losing position. Otherwise, this is a winning position again. Like R minus 1, because I am looking at the prefix part, R comma C. And at last, if there are no winning position, then the first player loses, otherwise the second player loses. This was my idea for E2. Any questions on this before I call it a day? Like any questions related to any problem today or anything in general, like I would be happy to answer it. like for E2, for problem D, I was mostly betting on no one hacking my solution. So I'm not sure if it's solvable or not. Like, let's hope like the legendary masters have solved it. So like you can probably post solution link here, but what I remember is like YouTube blocks all the links. So like YouTube will end up spamming blocking your link. You can probably use Discord. So like I see like the most important question people have in the chat is like how do they improve like probably from how to reach specialist grandmaster or what a topic like let's say dating X. You can probably use Discord for solution link etc. So for that my suggestion is like you can probably join my Discord server. There I have a channel which says roadmap to read in 2 minutes. Basically it mostly contains my advices here. Like mostly a clickbait channel, but my advice is like first advice I have for people is just participate in AdCode or Beginner contest. Like don't skip them. Like they are the first one you should do. And probably like sometimes people say like what all topics they need to reach let's say especially something here. So USA CEO guide is a pretty good guide. It contains different sections marked as bronze, silver, gold, and platinum. Bronze is div 3, silver div 2, gold div 1, and let's say platinum harder than div 5. So let's say if you want to reach up till expert or something, then you can probably start by reading these topics here. Like for example, graphs, flood, introduction to tree algorithm or topic is there. And like there are some theory here and then there are practice problem. Like this can be a starting point to do here. But my first advice is like participate in contest and try to solve problems. Upsolve means try to solve the problem after contest which you could not solve in the contest. And then if you have still more time, then you can probably refer this guide for new problems. Or there is a CSCS problem set as well, which contains a lot of standard problem like graph algorithm, etc. You can try out solving these problems as well. And then there is one competitive programming handbook as well, which contains around 300 pages. It contains a theory about lot of topic. You can probably read this one as well. I am weak in recursion. Should I do DP? Like probably the first thing you need for DP is to get good at recursion. So my suggestion would be try to solve a lot of recursive problem, then probably jumping on to DP. Is in-out and rerouting same? Like I don't really know a lot of algorithms by name, and I don't know what do you mean by in-out DP or rerouting DP. And then there are questions like what did I did when I wanted to was below or expert. Like this is what I used to do. You can probably read out here. And then what I used to do when I was targeting 2100 rating and so on. And like one critical advice is from opening is to get better at X, you should do X. So if you want to, let's say, reach specialist, a better would be try to solve problems which are rated 200, 300 more than your rating. Is the contest rated? I hope so. Like I'm betting on like the legendary grandmasters that they have the correct solution for D. Like I don't have a correct solution for D, but this does not mean everyone, all 200 people have the wrong solution. If everyone has a wrong solution and authors also don't have a wrong solution, the contest may end up being unrated. But right now I am betting like at least one person has a correct solution. So I'm hopeful it's rated, but if it turns out no one has it, then might be unrated. Like one critical thing is like Like Umnik did not submit this problem, so maybe he had some counter test cases, etc. there. Like had Umnik submitted, I would have been more confident than the contest history there. Let's probably see. Like you can watch out for Codeforces comment. Like I'm pretty sure someone would have posted it here. I would have made that comment, but I was busy with the stream. It looks like no one has complained about unexpected vertex so far. Then I think I will do the needful. Yeah, thanks for rank 2. Like I definitely had a counter test case for my D. Like let's just say like test cases were not strong enough and no one hacked here. So I ended up being rank 2. So thanks everyone for joining today. I think I will end the stream now. Unless people in the chat have some more questions. After reaching people, how much time you think for moving in the next rank? Like different people have different backgrounds and everyone has different time to reach a particular rating. And it does not make sense much to discuss like how much time someone needs. Like probably you should focus more on trying to solve problem rather than. So thanks everyone, and I think I will end the stream now. Like I don't really know. Like I will definitely complain. Like my solution, I have a verdict where author solution get a TLE, but at the end of the day, it's up to them. So like right now the rating is updated. Let's see. Like I'm hopeful. Like people do have a correct solution for this, but if no one has a correct solution, then it will be unrated. And I'm betting on legendary grandmasters that they have a correct solution. So thanks everyone for joining today, and I think I will end my stream now.